Guys, welcome back to our channel Get This Soon. In this video, we are going to discuss about scheduling types and scheduling criteria in operating system. This is the 14th video in the series of operating system. If you haven't watched my previous videos yet, then make sure you watch them. As I said, this is the 14th video. In all my previous video, we have discussed about program, we have discussed about process life cycle, the queues, the schedulers, and CPU input output bursts and their cycle, everything. Also, we have discussed about context switching, right? Now, it is time to learn about scheduling types. How can we schedule different processes and also understand the scheduling criteria? Once we know about these two things, then we can move forward to the scheduling algorithms from the next video. So, let's get started with the scheduling types and scheduling criteria. So, basically, we have two types of scheduling. One is primitive and the second is non-primitive. First, let's start with the primitive scheduling. In preemptive scheduling, the OS has the ability to interrupt and temporarily suspend the execution of currently running task. So, for example, process A is executing. So, if it is preemptive scheduling, we can stop process A and we can continue or start process B if we want to start. And this interruption is often based on task priority. For example, as I said, process A is doing its execution, and we came to know that process B is having higher priority, and process B have to execute now immediately. So before completing process A itself, we will stop process A and we will start with the process B. And this type of ability to suspend the current running task and shifting to another task is known as preemptive scheduling. Now let's see about the other type of scheduling, that is non-preemptive scheduling. In non-preemptive scheduling, the task run uninterruptedly until it completes its execution or it voluntarily releases its control. So if process A is running and if you want process B to start also, until and unless process A is completely done or if process A want to exit voluntarily, you can't start process B. So if a process gets started, the next shift to the other process will be only if the process A completes its execution or itself stops. So I hope you understood the differences between preemptive scheduling and non-preemptive scheduling. So in the upcoming videos, we will start with the types of preemptive and non-preemptive scheduling. Moving ahead, now let's discuss about the differences between preemptive scheduling and non-preemptive scheduling. Here, as we know, in the preemptive scheduling, the resources are allocated to process for a limited time. In non-preemptive scheduling, once resources are allocated to a process, the process holds it till completes its burst time or switches to a waiting state. So, in non-preemptive scheduling, as I already said, the process runs uninterruptedly. Therefore, the process holds the resources completely till its burst time. Moving ahead, in preemptive scheduling, the process can be interrupted in between. In non-preemptive scheduling, the process cannot be interrupted until it terminates or switches to the waiting state. Moving ahead, in preemptive scheduling, if a high priority process occurs, like if process A is running and process B is having high priority and it wants to run, then low priority process may start. So then A will be stopped and process B will continue. Whereas in non-preemptive scheduling, if a process with long burst time is running on the CPU, then another process with less CPU burst time may start. So until the long burst time process which is running on the CPU gets completed, the next process will not start. Moving ahead, preemptive scheduling is cost associated. In non-preemptive scheduling, it is not cost associated. Moving ahead, here are just a few examples of preemptive and non-preemptive scheduling. Unix, Linux, almost all types of Windows comes under preemptive scheduling. In non-preemptive scheduling, we have an example of Windows 3.1 X. So we have understood the scheduling types, understood the differences between them and everything. Now let's understand the scheduling criteria. So what do you think by scheduling criteria? So as I already said a couple of times that we are going to learn a couple of algorithms, we need to understand the best scheduling algorithm for the particular situation or for the particular process. To understand which is the best scheduling algorithm, we need to understand few things, like few criteria we need to understand so that we can choose the scheduling algorithm for our situation. So the first thing we have is CPU utilization. CPU utilization is a percentage of the time that CPU is actively executing process. So generally a high CPU utilization is desirable, and it is calculated in terms of percentage, and the wasted, how much CPU is not working, how much time the CPU is idle. All these things is calculated in the terms of CPU cycles. So like zero CPU cycles is wasted. Like this it is counted. So basically CPU utilization is a percentage, like 90% of CPU is utilized. In these terms we use the factor CPU utilization. Moving ahead, we have throughput. Throughput is nothing but the number of processes completed in a given unit of time. It can be like 10 processes completed per second or one process completed per hour. So all these things, how many processes by given time is known as throughput. So how this helps? So throughput helps in overall efficiency in the processing task. Next, we have arrival time. Arrival time is the time when a process enters the ready queue, indicating its readiness for execution. So, whenever it enters the ready queue, that time is known as arrival time. Burst time is nothing but the CPU execution time. How much time this process took to execute, how much time the CPU took to execute is calculated using burst time. Moving ahead, we have completion time. Completion time marks the point when a process finishes its execution. Once arrival time is like when it is entered the ready queue. Similarly, completion time is the time when the process is completed, when the process output execution everything is completed. Next, we have response time. Always remember, response is not output. Response time is the time when a request is submitted until the first response is produced. If you're waiting for some input or output and you ask the system and you got a response, the time you waited for the first response is known as response time. It is not the final output, it's just the time you waited. Moving ahead, we have turnaround time. This metric measures overall time a process take from submission to completion. Turnaround time is calculated by completion time minus arrival time. Moving ahead, we have waiting time. Waiting time represents the amount of time the process spent in the ready queue, waiting for their turn to execute in the CPU. So this waiting time is calculated by turnaround time minus burst time. So that's it from my side. I hope you understood. To do the scheduling algorithm problems, you need to know this concept very, very well, all these criteria very well. So I hope you understood. If you have any doubts, make sure you comment below. Thank you so much for watching till the end. Please like, share, and subscribe to our channel. Get please soon.